Hey, pre-algebras. So this is our practice guide, set 1 questions. This is not review video number 1, LeCompte. This is review video number 2. Let's fix that. Don't know what you're saying, guys. Totally said 2 the whole time. But you know what? You never know if you find mistakes. As I said before, only one student found the mistakes in the first video. If you go back and find them, maybe there'll be something in it for you, like a bonus point or a merit. All right, let's get to work. So remember, these questions come from a practice guide that's provided by the state. So I want you to recognize that these are totally questions that are written by Virginia. So this isn't even ones written by me. Okay, so on this question it says the volume of a square-based pyramid is 588 cubic inches. The height of the pyramid is 9 inches. What is the area of the base of this pyramid? We need our formula for the volume of a square-based pyramid, which is 1/3 big BH. If you look, remember what we talked about with an equation or a formula. If I have a formula with more than one unknown, in this case 1, 2, 3 unknowns in the original formula, if I have 2 of those 3 things, I can solve for the last one. So let's plug in the volume, which is 588. We still have 1/3 times big B times 9 for the height, and we're finding big B. Well, look here, 1/3 of 9 is 3. So I have 588 equals 3b, and I can solve that by dividing by 3. And that's going to give me 128, let's see, 9, 6. So big B is 196. The other method here would be to take my formula and try each combination, A, B, C, D, try 1/3 times 196 times 9 and see if that gives me 588. Try 1/3 times 65 times 9 and see if that gives me 588, and so on. Okay, but the correct answer there was A. If you got it, good for you. Moving on. Equation. This equation is more complicated than what we're used to because 1, it's got variables on both sides, and 2, it's got this fraction over here that is confusing. So I want you to first remember that we talked about how to get rid of a fraction like that. Multiply both sides by that denominator, and that fraction is going to cancel out. And this is 8p equals negative 3p minus 6. I'm going to add 3p to each side, giving me 11p equals negative 6. I'm going to divide by 11, giving me p equals negative 6/11. So that's my correct answer here. I could also plug them in and work backwards. That's a lot more complicated on a question like this, but it's still doable. Remember that negative 6 divided by 11 is the same as negative 6/11 on your calculator. Okay, next question, we have an inequality. So the first thing I notice is that there is a fraction involved. And we already had a discussion about this in class. I want the fraction gone. So what we learned to do in class is we learned to take every term and multiply by the least common denominator. Now the least common denominator here is 2. So we're going to multiply everything by 2, giving me negative 6a for the first part. 2 times 1/2 is 1, and then 16. If I subtract 1 from each side, I get negative 6a is less than or equal to 15. And I can divide to solve, noticing that I have to flip my symbol around, and I'm getting a negative answer. Divide them both by 3, it's negative 5 halves. Negative 5 halves. So 15 over 6, dividing them both by 3. 15 divided by 3 is 5. 6 divided by 3 is 2. So that's A is greater than or equal to negative 2.5. So we want to look for the one with a point at negative 2.5. Negative 2.5 is going to be right here, right there, and right here. And we want the one that is greater than. So we want D. And D is the correct answer. If you got C, what was probably your mistake? Symbol flipping. It was probably symbol flipping. Okay, onward. Excuse me. What property justifies the work between steps 2 and 3? In step 2, we have 2/5 x plus 5 plus negative 5 equals 9 plus negative 5. And on step 3, we have 5 plus negative 5 has been replaced with a 0. And that's the only thing that we're to be looking at in this problem, guys. That's the only thing. Which property tells me only that? Notice the rest of it is still the same as it was before. The only one that tells me that is additive Inverse, opposites, inverse. -5 and 5 add up to 0. A rectangle shown, the rectangle shown has a length of 0.9 centimeters and a width of 0.4 centimeters. A circle is drawn so that it touches the rectangle at 2 points. What's the area of the shaded region? Well, we remember that we learned we have to find the total area and subtract the unshaded part to get just the shaded part. So the total area is the area of that rectangle. And the area of a rectangle is length times width. So 0.9 times 0.4. The unshaded area is the circle. And the area of a circle is pi times the radius squared. But they don't give me the radius. I have to recognize that the diameter of my circle is 0.4 centimeters and then cut it in half to find that 0.2 centimeters. So pi times 0.2 squared. Now using my calculator, I'm going to go through and do the math on each side. 0.2 squared is 0.04. So 0.2 times 0.2 is 0.04 times 3.14, and that's 0.1256. And then we're going to subtract. And we get 0.2344. Meaning the one with the closest answer is going to be B, 0.23. So find the total area, subtract the unshaded area, and that's what we got. Notice that we needed to write it out, including formulas, to get it right. Rhea had a score of 70 on her first quiz and a score of 77 on her second quiz. What's the percent increase from one quiz to the next? We've had a lot of this lately. Remember that it's change over original equals percent over 100, and the percent is what we do not know. So the change here is second quiz minus first quiz. So 7 over original, which is 70 on her first quiz, equals x over 100. 70 times x equals 7 times 100. And when we divide, we end up with 10 as our answer. Triangular prism. So we have a triangular prism of which to find the area, surface area. So I need my formula for the surface area of a prism. Surface area of a prism is, sorry guys for that lovely editing jump. Surface area of a triangular prism is, well, I actually may have discovered a problem. Yet another editing jump. Sorry guys for why we had trouble with this. It appears that some of the formula sheets we have in the classroom are not correct. HP plus 2 big B. That's our formula for the surface area of this prism. H is the height of the prism, P is the perimeter of the base, and big B is the area of the base. So I need to be able to recognize here how to find all of those. So the first thing I need to recognize that if it's a triangular prism, the base is the triangle. And that makes sense because if I'm going to find the area of a triangle, it's 1/2 times base times height, and the base and the height must be perpendicular. In this case, it's the 4 and the 3. Whichever way you want to look at it, whether one is B and one is H or vice versa, it's still going to work. 1/2 of 4 is 2 times 3 is 6. So the area of the base here is 6. The perimeter of the base is the sum of all 3 sides right here. 3 plus 4 plus 5. Which comes out to be 12. And the height of the prism is 2. So the surface area of this prism is 2 times 12 plus 2 times 6. HP plus 2 big B. The secret to figuring this out is absolutely, and has always been, writing out your work. We get 36 square centimeters for the surface area of the triangular prism. This one and one more left. I know we've seen this question a few times before. 2 triangular prisms are shown. They have bases with the same area. The volume of prism N can be found by multiplying the volume of prism M by what factor? Well, we only changed one dimension, and we learned that when you only change one dimension, it changes the volume by the same amount. So if we change this dimension by multiplying by 4, we change the volume by multiplying by 4. To go from, so the volume of prism N can be found by multiplying prism M by 4. What if it said to go the other way around? How would I find the volume of prism M if given N? You would multiply by 1/4 if you were going the other direction. Probability question with a type it in. The deck contains the cards that are the same size and shape. 5 green, 4 red, 2 blue, and 2 orange and 1 blue. So 5, 4, 2, and 1. 9, 10, 11, 12. There are 12 cards in the deck. We're going to take the cards, we're going to not replace it, and then randomly get a second card. We want to know the probability of blue, then red. And again, it's without replacement. We start off with 1 blue card out of 12 times. We took a card out, so make it 11. And there's 4 red cards. Simplify by dividing both of these numbers by 4. 1 times 1 on top, 3 times 11 on the bottom. There's our fraction. 1/33 gives us our fraction answer to put in the box. You guys will see yet another one of these reviews coming at you for tomorrow night's homework, and I will see you guys in class.